Have you ever wondered what makes your smartphone smart, or how your car knows when to brake? The answer, my friends, is hiding in plain sight. It's not magic, but it's close. Tiny microchips, smaller than your fingernail, are the brains behind these everyday miracles. From your TV to your toothbrush, these miniature marvels power our modern world. But have you ever stopped to think about how these tiny geniuses are made? It's a journey that takes us from the mundane to the magnificent, a testament to human ingenuity. We begin with something so ordinary, so commonplace, you might be surprised. Sand. Yes, you read that right, plain old sand. This humble material found on beaches and deserts around the globe holds the key to our technological future. So buckle up, dear reader, as we embark on this fascinating adventure to uncover the secrets of how microchips are made.
Sand, as it turns out, isn't just for sandcastles and sunbathing. Hidden within those tiny grains is a chemical element called silicon, the star of our show. Silicon is a semiconductor, a material with a special ability to conduct electricity under certain conditions, making it the perfect ingredient for our microchips. But before we can transform sand into technological gold, we need to extract and purify the silicon. This involves a series of chemical reactions and processes designed to remove impurities and isolate the silicon we need. Imagine a giant sieve separating the wheat from the chaff, and you'll have a good picture of what's happening here. The end result? Ultra-pure silicon, sparkling and ready for its transformation. If you enjoyed learning about the journey from sand to silicon, don't forget to like, share, and subscribe for more fascinating insights.
Picture this, a giant washing machine, but instead of clothes, it's filled with molten silicon. That's essentially what happens next. The purified silicon is melted down into a giant crucible, a container that can withstand incredibly high temperatures. Then, through a process called Czochralski growth, a single silicon crystal is slowly pulled from the molten pool. Think of it like making rock candy. You start with a sugar solution and slowly dip a string into it. As the solution cools, sugar crystals form on the string, creating a large single crystal of sugar. The same principle applies to silicon, resulting in a cylindrical ingot of pure, single crystal silicon. If you found this fascinating, don't forget to like, share, and subscribe for more amazing content.
Our silicon ingot, now cool and gleaming, is ready for its next transformation. It's sliced into thin, round wafers, like a loaf of bread being turned into slices. These silicon wafers are incredibly thin, often less than a millimeter thick, and incredibly flat, polished to a mirror finish. They are the canvases upon which our intricate microchip designs will be etched. Each wafer can hold hundreds, even thousands, of individual microchips. It's on these pristine silicon discs that the magic of microchip fabrication truly begins.
Light, camera, chip design. The magic of photolithography. Now comes the really fun part, creating the actual circuitry of the microchip. This is where photolithography comes in, a process that's similar to developing a photograph, but on a microscopic scale. Imagine shrinking yourself down to the size of an ant and stepping onto the surface of a silicon wafer. First, the wafer is coated with a light-sensitive material called a photoresist. Then, a detailed pattern of the chip's circuitry is projected onto the wafer, much like shining a light through a photographic negative. The areas exposed to light undergo a chemical change, allowing them to be washed away, leaving behind the desired pattern on the wafer.
Etching away, carving the circuit city. With the blueprint of our chip etched onto the wafer, it's time to carve out the actual circuitry. This is where etching comes in. The wafer is exposed to a special gas or plasma that reacts with the exposed areas of the silicon, etching away the material and leaving behind the desired pattern of trenches and channels. It's like using a tiny, incredibly precise chisel to carve out the intricate pathways of a miniature city. These trenches and channels will become the interconnections between the various components of the microchip, allowing them to communicate and work together.
Doping giving silicon superpowers. Our silicon wafer, now adorned with its intricate circuitry, is almost ready to become a fully fledged microchip. But first, it needs a little something extra to give it the ability to control the flow of electricity impurities. This process, called doping, involves introducing carefully controlled amounts of other elements into the silicon crystal lattice. These impurities alter the electrical properties of the silicon, creating regions that can act as conductors, insulators, or semiconductors, depending on the type and concentration of impurities added. It's like adding a sprinkle of magic dust to our silicon, transforming it from a simple material into the building block of complex electronic devices.
From factory floor to your hands testing and packaging. Our microchip, now complete with its intricate circuitry and carefully engineered impurities, is almost ready for the real world. But first, it needs to be tested rigorously to ensure it functions correctly. Specialized equipment scans the chip, checking for any defects or errors. Only the chips that pass this rigorous quality control process make it to the next stage packaging. The individual chips are cut from the wafer and encapsulated in protective packages, complete with tiny metal pins that allow them to connect to other components. This packaging protects the delicate chip from damage and provides a way for it to communicate with the outside world. Finally, the finished microchips are shipped off to factories around the globe, ready to be assembled into the electronic devices we use every day. If you enjoyed this video, don't forget to share it with your friends and family. Encourage them to visit our channel regularly for more exciting content.